Previously, we ended at section number 7, and in this video, we're going to continue on to the next section of the SDS, and that's section number 8 that focuses on exposure controls and PPE. Alright, so this section basically gives us information on how to prevent exposure. That's why it's called exposure controls, okay? Again, use some common sense here. I think that you'll be fine if you do. PPE is also going to be listed. So, goggles, gloves, lab coats. What should I wear? Respirators? When I work with this chemical, whether it's a solid, a liquid, or a gas. You're also going to be focused on limits in this section. So the limits will basically be, of course, how far can you go before exposure takes control and provides you some type of health hazard. So we all know that we're going to be exposed to it in some form or some fashion. A little bit, though, might not hurt us, but there's going to be a point where too much of it is going to start to have side effects. So that limit, that exposure limit, is going to give me an idea of how much I can expose myself to before starting to get worried, okay? But again, it's focused here on industrial use. Lab workers might not need this information. And the reason that I say that is because you're working in a lab, you're working with a chemical, and these things have already, or they should have, already been thought of by the time you go into that method and that test and begin to do the testing that you need to do. Okay? So the industrial use basically means these are managers of certain facilities that will go in, they will take a look at the chemical that you're going to be working with, they're going to have this exposure limit and personal protective equipment idea already in mind when they write the method. And when they write the method, they will give you that method, and then you follow that method. So this is kind of what helps determine some rules in a laboratory. So they want to make sure that this exposure limit does not go over the limit, and they also want to make sure that you have the correct PPE that you need as a worker when you work with these specific chemical, all right, or this specific chemical. So the uses here, again, would be employers, maybe, laboratory managers. Even you as a laboratory worker could use this section just to get an idea if they did do their job. Did your manager or supervisor do their job? And look up the SDS information to make sure that you are not exposing yourself to a chemical that's very hazardous. So employers, lab managers. Some companies have what we call environmental health and safety departments. They also would utilize this section of the SDS. But again, everything here is going to be very general. So if you, as an entry-level worker or student, goes to this section, you might see a couple of listings that are there, but they're going to be very general. And this is the common theme that we've seen with SDS already. They're going to be very general statements. They're not going to give you specifics, and it's up to you to take the next step and utilize some of those other resources that we've talked about in order to find out what exactly is dangerous and what is not. What should you be wearing and what should you not be wearing? Keep in mind, SDS is the one that said that you need an eye wash if you expose yourself to DI water. Okay, so keep that in mind. All of these things are very general and very vague, and they're written that way on purpose. So section 9, next section. Section 9 is going to be the physical and chemical properties of the stuff that I'm working with. Everything is located here, and most of it has been confirmed. So what kind of things would this be? Well, we're looking at density values here. We're looking at boiling points. We're looking at melting points. We're looking at formula weights or molecular weights. Both of those are kind of interchangeable now. But those are the types of things that we're looking for. Solubility. If it is soluble, well, what solvent is it soluble in and how much can go? So Section number 9 is probably the most relevant to us that's working in a laboratory because we might need some of this physical data to do what we're doing. So, for instance, let's say that a company manufactures aspirin and they bring the aspirin to us and they want to know the purity. Well, one of the things that we could do would be to take a melting point of the aspirin that they have submitted to the lab. So we would take the sample over to a melting point apparatus. We would get the melting point of this compound and report that melting point in degrees Celsius. Well, we can kind of cross-reference that melting point to section 9 to make sure that our melting point that we have obtained in the lab is close to the expected value underneath this section. Now, section number 9 is confirmed. They've probably have gotten this information from somewhere else. So there's plenty of online resources that you could use for this purpose. You don't have to go to the SDS in order to get melting points and boiling points and densities. These things are even available on something like Wikipedia. So yeah, section 9 is great, but do we use the SDS for section number 9? And the answer is no, because there's other more convenient resources out there for me to use, many of them on the internet, that I can get this information within a matter of seconds. So that's what I'm going to say about section number 9. It helps us assess the risk of certain chemicals. So for instance, the solubility and the densities, it will give me an idea of how I should be handling it, what I should be mixing it with, what shouldn't I be mixing it with. It'll give me an idea of the chemical and the method that I'm trying to use with that chemical, but it is useful in experiments. I might need some of this physical and chemical property information at a certain point throughout a laboratory experiment. But again, I can get these resources from somewhere else. So this is lab worker suited, and it's probably the most suited for laboratory workers and entry-level employees and entry-level students. The problem is that SDS is really not the go-to in order to obtain this information. It's really an online resource that I can just type into Google, get the density of whatever I'm working with within a matter of seconds, versus taking the time and looking up the SDS in a database or getting the SDS book down in the lab and trying to dig through a folder and trying to find what I need to find. All right? Okay, so section number 10. Section number 10 is going to focus on stability and reactivity. So we're talking about the stability of a chemical. That basically means how safe in a way is the chemical itself. If it's not stable, then I'm going to have to maybe handle it with care. I'm going to have to make sure that it's very comfortable and very happy in a laboratory situation that I'm putting it in. But stability, if it's kind of a big boy or a big girl, then it can kind of handle on its own, and I can jar the jug, or I can swish around the liquid, or I can add things to the liquid, and nothing temperamental is going to happen. It's going to give me an idea on the conditions to avoid when I'm in the laboratory or when I'm working with this chemical. So, you know, this statement might say keep away from all salts or keep away from lithium type compounds. Well, this gives me an idea. Okay, well, if I look at the method that I'm doing, I'm not using any lithium. So because of that, I don't have to worry about the stability or the reactivity of the compound. I don't even have lithium in my lab. So that's even better, right? But if I do have lithium in the lab, and we do, then I need to make sure that I take all the steps necessary so that these two will never cross paths, okay? So just because the lithium is not out that day doesn't mean that lithium has not been out the day before or a couple of days before, and a cross-contamination could happen, and I might not see it coming, but all of a sudden this cross-contamination could maybe make this chemical explode. So it will give me an idea of where I should maybe use this chemical in my laboratory. What room would be best suitable for it? What things do I have to watch out for to make sure that nothing is going to cause any kind of accident or incident to happen? So conditions to avoid when working with the chemical. It's also going to tell me incompatibility for that reasons, right? So incompatibility basically means where kind of should I store it? What doesn't it like? Does it react with water? If so, I need to keep it in a water-free environment. I need to keep water sources away from it. I need to make sure that I'm taking the necessary steps in order to make sure that this stuff is going to stay good. The same thing happens with refrigerated chemicals, right? So if I get a chemical in the laboratory, section number 10 might say this chemical needs to be stored at 4 degrees Celsius or below. So 4 degrees Celsius is typically in the fridge. That's where I need to put those types of chemicals. So keep that in mind when you start talking about stability of molecules, and this kind of relates to storage of molecules as well. We also need to talk about the side effects or the side products, the side products of chemicals, especially with decomposition. Over time, these chemicals are going to break down. They have expiration dates, just like your milk in your refrigerator. And after an expiration date, these chemicals can start to break down and give me side products, meaning it's no longer what I think is in that jar, but now it's side products or decomposition products that are completely different than my starting material. They have different reactivities, they have different stabilities, they have different physical and chemical properties. So expiration dates are very important. We got to get rid of stuff. We got to throw stuff away. We don't need to keep old stuff in the lab. So for that reason, these side products can be dangerous. They can cause me problems that I am not expecting in a laboratory. And section number 10 is going to focus on that. It's going to focus on this compound. If it does break down, how long does it take for it to break down? And what are the things that I need to watch out for if the thing does break down into side products? The stuff happens with what we've seen before is ether. Ether is a liquid. Ether is pretty safe. It's flammable, but it's safe to use in a laboratory, and we've used it before in the past and we'll continue to use it. The problem is that ether, when it reacts with a little bit of heat and a little bit of light, can decompose in a way, and it can form a side product, and that side product are peroxides. And these peroxides are very explosive. So this is why bomb squads have to come in sometimes and remove jugs of ether from a laboratory because of the peroxides that it can cause. So all of these are side product related. So uses here, I'm going to say, are very useful for a lab worker. Okay, it gives me an idea of things to watch out for. It gives me an idea of how much care do I have to put into the thought process of handling and reacting with this chemical. And then even in storage in a way. It's not necessarily saying storage in the title, but it gives me an idea of where these things should be kept and what they should be kept away from. That's the thing that section number 10 is going to tell us. So reactivity, incompatibles, they're extremely useful to us as a lab worker. And this section is also great for emergency personnel, EMTs maybe, and firefighters. The reason is because if something breaks out, let's say an explosion happens because of the ether, they can look up this SDS and they can go to this section and they can kind of clearly see what this was maybe the cause of. Okay, so that's going to be section number 10, another section that we can utilize for our purpose, but again, very general statements for the most part. Section number 11, toxicological information. Here we're focused on toxicity studies. Toxicity studies are typically with animals first. They will give me an idea of what they've done with it to see how much could they go before they poison a poor little rat in a laboratory with it. It's also going to talk about human exposure here as well. So how far can we push the boundaries before we start seeing a side effect or before we start seeing these chronic ailments that happen because of the exposure to the chemical. So I'm going to put two words down here, acute and chronic. Acute, of course, means short term. and then chronic would be long-term. It's the chronic studies that are the problem because these are long-term. So how long is long, right? So depending on the age of the chemical and when it was manufactured and produced and when we know information about it and when the studies began, if we've got a chemical or let's say even a medicine that we have prescribed to a consumer or that we work with in the laboratory, and let's say 30 years from now, someone ends up with some type of kidney damage or liver damage or cancer. Was that because of the exposure to this chemical or to this medication that they used back in the day? So chronic is going to constantly change. The acute one is typically a little bit easier to see because if we expose yourself to the chemical, then you're going to immediately feel the effects if there's going to be side effects on it, right? So these are very short term, and most of the time if you remove the chemical from the lab or if you remove yourself from the exposure to the chemical, these acute short-term toxicities will basically go away. At least you hope they do, and most of the time they do. The problem is that the chronic ones, sometimes we do not see coming depending on the age of the information that we know according to the chemical. So chronic studies are always going to be a pain in our butt. This is also one of the areas that the SDS faults. So if something's going to be wrong in the SDS, it's probably going to be here in the chronic long-term toxicity studies because, again, how long-term is long-term? So the uses here would, of course, be for safety. It'll give me an idea of how safe this compound is overall, right? And then I've got to take that information and I've got to kind of interpret that information in a way that is safe for laboratory workers or for you when you expose yourself to this chemical. So limited information about toxicity studies, that's the problem with this section. It is limited information and it's often incomplete. And chronic is very hard to evaluate. It could be old information, but it does give me a general idea of the safety of the compound. And that's sometimes really all that I need. That's all that I'm worried about. If I think that this compound is too hazardous to work with, or if I think any slight inkling that this compound could cause a chronic long-term health effect when you expose yourself to it, then I'm going to make sure that the lab takes special precautions and that you take special precautions to wear the appropriate PPE and to handle and store this chemical the proper way. So this section is pretty important to us in our field, in our career, and section number 11, though, is going to be very general like the rest of the SDSs. So I'll take this information and then maybe I need to expand upon that if I need to. Okay? So in the next video, we're going to concern section 12, and hopefully we can go through section 12, 13, 14, 15, and 16, and then we'll be finished. So if we can crank out these next ones in this next video, that might be the last one that you'll need to watch for this lecture module.